Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to today's webinar, Design, Construction and Maintenance of Assets. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them and their cultures and to elders past and present. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Dulux Protective Coatings. Dulux Protective Coatings is one of the leading manufacturers and suppliers of protective coatings within Australia, proudly protecting Australia and New Zealand's assets for over 90 years. A comprehensive range of protective coatings help protect, maintain and enhance assets and infrastructure across diverse industries, including bridges, water and wastewater, rail and road transport, public facilities, commercial building, mining and a wide range of heavy industrial settings. Products are tested specifically for Australian and New Zealand conditions. With the capability to manufacture locally, coupled with an extensive network of over 230 stores, their experienced and trained technical consultants have the means to ensure the right coatings are supplied for your specific project on time and with confidence. We thank Dulux Protective Coatings for their continued support. Today, we will hear from 3 speakers, and I'd now like to welcome our first speaker, Samuel Hughes, Coatings Engineer at Fressinet, Australia. Sam is a remedial engineer specialising in coatings with 8 years of experience in the remediation sector. He has worked on assets such as bridges, power stations, wharfs, residential towers, stadiums, rail lines, reservoir pipelines, mines and treatment plants. Sam provides internal support to his project delivery teams, as well as external advice and solutions to clients, including condition assessments, maintenance planning and coating methodologies. Please welcome Sam Hughes.
Thank you very much for the introduction. I'll be giving the presentation today on quality processes and warranties within the protective coatings remediation industry. First, I'll do a quick little intro to myself. I've had about 8 years of industry experience, worked on many assets such as bridges, power stations, wharves, residential towers, stadiums, rail lines, reservoirs, mines, treatment plants, and many, many others as well. Been lucky to travel all around Australia for this, so I've managed to have a wide range of experience in the remedial engineering, design, coatings, and construction industry. What I really like about it is keeping history going for the next generation is the mindset I always keep in. Sustainability in mind is always key for me. So in essence, this presentation is going to boil down to quality management in terms of remediation, especially in the protective coatings and corrosion management side of things to help extend design life and renew an asset. And it comes down to quality assurance, quality control, warranties and specifications as the overarching theme of this presentation. And I'll get into each of those 3 as we progress through the presentation. But my core points that will loop back into the QA/QC theme is, why is QA/QC important for project warranty? How do we structure our QA/QC for coatings, especially in the remediation industry? And what guides our QA/QC warranty requirements? We explain all this and get some real life experience. I'll be touching on a couple of key case studies that I've experienced or had assistance with on my time with Fressinet Australia. First, those will be large complex assets such as stadiums and other public infrastructure, even rail, bridges, other reservoirs are some of the other things we do. But I feel like these stadium jobs really showcase the importance of thorough, robust, quality systems to track and ensure compliance with the warranty and contract, as well as achieve the desired durability. Well, I'll also utilize a private bit of infrastructure, residential tower building, still under remediation by Fresnay this year, with a different sort of risks involved, but it's a similar idea of quality tracking and robust QA/QC requirements. Why is QA/QC important? That'll be our first discussion topic today. So we've got two things there: quality control versus quality assurance. People get them confused all the time. They aren't the same thing, but they do work hand in hand with each other, and both are important for ensuring we do the right thing by our remediation project. So why is it important, and what does QA mean as part of that? So QA is important for the contractor to provide reassurance, which is quality assurance, hence the name. And it's reassurance that the specification was followed step by step. It is documented evidence of our compliance. QC, on the other hand, is important to demonstrate that bugs are being controlled and busted before a final product is delivered. And it's a system in place as a foundation for QA to succeed. Overall, together, they provide confidence in the asset owner that the product has received a quality outcome. So QC is like our system in the background that lays the foundation for our QA to spring up from and showcase what we've done for the project. Typically, a QC system within a company, like a company management system, set of documents, policies, and procedures, which come in templates or set methodologies that the team can lean on, with the QA forms then being what you fill out on site to track the works in accordance with the warranty, the contract specification, or the Australian standard. Again, why is it important? Well, we talked about how it's being a set of documents to give assurance to the clients, also to show that non-compliance isn't happening and that we are being compliant with what is required under Australian standards, specifications, and warranties, which all are linked together. It is like a recipe for a meal, as our specification. It's a step-by-step process to deliver the desired quality outcome. We need to follow this to ensure the required meal is delivered to the customer. Each one of these parts forms a greater whole, and we need to make sure each of them is done correctly, else the entire system likely won't work or be compliant. Again, QC sets us up with the tools for compliance, and QA is our record that we did comply. So in summary, QA is needed to demonstrate these steps to be followed, and by knowing these steps that require QA through the QC process, the steps themselves are more effectively followed, and then we can go through and check it all off. So to highlight studies why QA/QC is important, I'm going to show you here a series of pictures from both those case studies, showing you the depth and width of the project and how much was involved. So we've got here the roof structure of the stadium project. See quite a large complex steel framework, a lot of lattices. In amongst that's a lot of bolts too. So let me break it down into a mud map to try and simplify things. And again, that mud map is still quite complex, quite detailed. There's a lot involved there, a lot to track. Helped us a little bit. Then we go down again into an even smaller view, down to each individual chord, each point there, each node. And then this is what the guy's actually doing at the work front. So you can see how quite a lot of details needed there to track this properly. Paperwork is very easy to muddle up, get confused, and each one of these locations does need to be having its own robust set of QA steps and forms to ensure compliance with warranties, specifications, and the contract. If we can't read back on the QA, like a book or a recipe, back towards each one of these individual points, as shown by this worker blasting, then the whole system doesn't work, and we really can't rely on it in any way. So we have to have a robust set of QA to track each of these bits of remediation, and hence what makes a remedial project quite exciting problem to solve every time, because it's not typically being built from the ground up. It's something that is existing, and you're normally doing partial work on it as well, which makes it a bit more of a complex problem to track. Same again when we look at the residential tower case study, another complex structure with many different beams in different locations, but with the added risk of being quite high up and being zoned off with certain parts of scaffold. Again, we have to track all this, quite complex. We then as well use a mud mapping system to try and break this down. And typically our mud mapping is done based on access or how our client wants to hand it over. But if we don't do these right, if we aren't doing our QA right, we can fall into the trap of having one of these coding failures, which ultimately ruins the design life of the structure we're remediating, or brand new structures as well. We can have incorrect surface profiles, which means the paint can't grip to the surface. High humidity at application, which means moisture is underneath, creating bubbles or corrosion, and pinholing, allowing more moisture in. We need to prevent and identify coating failure and causation. In doing that, we have to assess the risks involved with these large case studies. Overcoating and older coating is one of the key risks there. As I said, remediation isn't brand new. It's an existing structure that we need to bring back to life, and that typically means it's spot work or partial work. We're also open to the elements, a lot of it being rope access on some of this or off scaffold, and that means that we can have environmental issues impacting it. All these things need to be tied back into our warranty and our QA/QC system. So how can we structure our QA/QC? As you saw before, we had to go through mapping system to try and break it down into something we can understand. Humans were visual learners, a lot of us, so it's very key to have something that we can visually track things down into, and that comes down to also a thorough folder structure with logical hold points, agreed hold points with both the supplier and the client, inspection regimes, documented trials if we need to do that to prove that a tracking system is going to work. One of my favorite things to do on any project is to do a trial, whether it's just a paperwork trial, doing a small area and showing that the system we're going to put in place can track that many, many times over. If the system only works in one situation, it's not going to be that useful for a large case study like we're seeing with these stadiums and the residential tower. And then clearly defined reporting methods and forms, which ties up into the other 4 points there. And really a robust and logical folder documentation recording system, as you can see an example on the right there, one of the projects we're talking about here, clearly breaking it down into all the different things we need to track. This ties into our inspection and test plans, which should have those agreed logical hold points listed. And many of these can be edited on site, which is great. Print them off, you handwrite on them, but they should still list all the checks and balances going on along the way. It should tie directly into your supplier's specification, because that leads also directly into your warranty, which in turn leads directly to your contract. So all these things need to follow on from each other. If the contract references a warranty, that warranty will reference a specification. That specification will have certain points that need to be ticked off to adhere to it, to achieve the warranty it's linked to. And then our ITP needs to reflect this too, or be more conservative than the specification to ensure that we are meeting the requirements under the specification and achieving our warranty. And all of these should then be signed off in a logical method, progressively, as well as tracked properly with the relevant forms. So we can see on the ITP here, we've got signed off, but we've got multiple different check forms there that we need to adhere to or record onto to hit this whole point. So you can see here some of these steps that were referenced in the ITP, such as bond testing, existing coating trials, testing the cleanliness and the thickness of these existing coatings. Again, cleanliness again. We've got daily ambient logs as well. That's our temperature check we've got to do constantly to ensure we are always compliant daily. Really though, the most important thing you can ever do from a quality management perspective, in my opinion, is photos. The paperwork can be done at a later date, even though it's best practice to do it as soon as you complete the works, if available to do so and in a safe location. And if you've got a good mapping system and you're labeling, like you can see we are doing on this example here, each spot has been labeled even on the asset itself or in the description of the photo. And many, many photos are being taken here, even of the recorded data on a digital gauge. Although we can download the data off our digital gauge, we can still have this photo as a backup. And a photo says far more than words ever could. And although we have photo editing software these days, it's very hard to fake some of these things, especially when you have thousands upon thousands of these as well. So my best recommendation always to structure QA/QC properly is photos of everything we do. And as I've already touched on, mud mapping is key. Having a clear logical sequence to it, making it read into a database of some kind also helps. But you can really see here and grasp the sheer amount of quality tracking we need to do and why it's so vital we do it properly. So the final discussion point, which won't take us too long, is what guides our QA/QC requirements, and really that's durability versus warranty and what those two things mean, which I believe one of the other presenters will be touching on further in regards to what warranty means and durability for a manufacturer and ultimately the stakeholder, the client. So where can we get something to guide our QA/QC? So we've got the Australian standards advisory bodies, WSA, ACA, AMPP. Client specifications can sometimes be internal and private documents. And the warranty, of course, which is either dictated by the client or in conjunction with the supplier. And ultimately, the supplier is your best person to go see for your warranty and your requirements for the product, because it is their product. They're the ones that have manufactured it, tested it, and know what it can do. So always go talk to your supplier. That should be your first port of call whenever you look to start a remediation coatings project or even a concrete repair project. Their material, they'll know what to do with it best. And finally, safety guidelines, which is a weird one to say on a quality project, but safety does dictate a lot of what we can do for quality. Because if we can't do it in a safe way, and it might be even the best, most top quality way of doing it, but if it's not safe, we really shouldn't be doing it anyway. So we have to always consider what is safe to do, and both to personnel and to the environment, before we consider what is the best quality to do. So sometimes that means we have to go and consult with the supplier and with the client, maybe look up different advisory bodies, get some expert opinions in terms of what we're going to achieve. And as one of the other panelists will go through, that could just mean going from a 5 to 10 year warranty or to a 25-year warranty, but more maintenance on the way, more visual inspections, more checks, or applying more coating to suit the fact that we can't do the better system. So there's always ways to work around it, but we should always consider safety to be key when we're talking about quality management and quality requirements. So thank you very much. That's the end of my presentation now. I hope I've imparted some knowledge there on my experiences with quality management around QA, QC, warranties, durability when it comes to the design life of remediation projects, and how we consult with our suppliers and clients and other stakeholders to achieve the quality result for the project and what needs to be done there. Thank you very much.
Thank you, Sam, for your presentation. I'd now like to welcome our second speaker, Adam Hockey, Business Development Executive at Dulux. Adam has worked in various roles in the Dulux Group for over 30 years. In his current role as Business Development Executive, he is responsible for specification writing, developing and presenting technical and industry-related presentations, working with key stakeholders to achieve the best outcomes for corrosion protection. Adam is a NACE 2 certified coating inspector and is passionate about education and providing technical support. Please welcome Adam Hockey.
Hi, as introduced, my name's Adam Hockey. I've worked for Dulux for 30 plus years, and I currently work in a role where I provide specification for major projects, infrastructure and maintenance for protective coatings in New South Wales. I'm also a branch president for the Australasian Corrosion Association, so I'm quite involved in managing corrosion. Today, we're excited to share some valuable insights into the design, construction and maintenance of asset for corrosion protection through the unique perspectives of the applicator, which we've had Sam talk about, the manufacturer, which I will run through, and the builder, which Nicole's talking through after my presentation. While we can't stop corrosion entirely, we can manage it effectively, and this presentation talks about that. This presentation will explore practical strategies for achieving the design life of structures through protective coating solutions. A common request I receive is for warranties that cover the coatings for the full design life of the structure. However, from a legal and technical standpoint, it's extremely challenging to determine whether a product has failed when it's already at the end of its expected performance. The good news is that protective coatings are not a one-time solution. They can be maintained, repaired, or refreshed over the time to help ensure that the structure reaches the intended design life. Each of these diamonds that I've got listed here in our risk management puzzle represents a critical element of the life of a protective coating system. Together, they form the foundation for achieving the most effective and accurate outcomes. And I will run through each of these a little more in detail. The first part of providing corrosion protection to achieve a design life and long-term protection for a structure is the specification. And for specification, we've got a National Construction Code requirement, which the Department of Fair Trading deems as mandatory. You would probably already be aware of this, but the National Construction Code has performance requirements. They either use a deemed to satisfy or a performance solution. A deemed to satisfy solution follows a set recipe, a set instruction of what's required to achieve the outcome required. And generally, a deemed to satisfy is the most common pathway for compliance when using the National Construction Code. For steel structures, for building classes 1 and 10, so more residential, there's a set recipe, a set deemed to satisfy instruction from the National Construction Code. For building classes 2 to 9, the NCC requires you to conform to meet the AS 4100 performance requirements. So for building classes 1 and 10, the deemed to satisfy instruction is referenced in section 6.3.9. And this outlines protective coatings specifications that are required to meet different requirements for different atmospheric corrosivity. So you can see on this screen, we've got referenced set systems, and these all align to the AS 2312, the Australian standard for corrosion protection. It's important to note for building classes 1 and 10, which are predominantly residential, all of these requirements require a workshop application because they require abrasive blast preparation of the steel. So it's a really important thing to understand when constructing a residential structure, that the steel is not just sent straight to site, it's actually prepared for corrosion protection before it's delivered. And this is a common thing that I'm seeing in the industry at the moment, where we've got steel installed and then they're asking for the corrosion protection of that. So we need to understand, to conform to the NCC, the steel needs to be protected before it's delivered to site. This was updated in 2022, 2023, because the previous systems were inadequate for corrosion protection. There was a lot of failure for corrosion in the residential side of construction. For building classes 2 and 9, so our more commercial and larger construction, the requirement is to conform to the AS 4100. So the AS 4100 is the standard for fabrication of steelwork structures. When we open up the AS 4100 and go to the corrosion protection section, it instructs us to actually go to another section, which is quite common in standards, but it tells us to go to Appendix C. And importantly, it also advises us that design components contained in this standard make no allowance of loss of material. So this is a really important part of protective coatings for the way protective coatings work and protect steel and achieve design life. And I'll cover this off a little bit more in the presentation. So when we go to Appendix C, it tells us to use AS 2312, the Australian standard for corrosion protection of steel. So I could have possibly saved us a little bit of time there and advised that to conform to the NCC, to the deemed to satisfy solutions, it is required to follow the AS 2312 standard. Part 1 is for mild steel, and Part 2 gives advice on applying duplex systems to hot dip galvanizing. Part 1 contains more thorough instruction on design of corrosion protection, so they should be both used in combination with each other. In most cases, if I ever go to a conflict or a failure for corrosion protection, I can usually work back through and find that possibly there wasn't something met that was suggested or recommended in this standard for corrosion protection. So what is design life when we're talking about corrosion protection? Design life is the life of a component, the life of an item, and the length of time between its placement into service and its exhaustion, its wear out. If we look at this staircase, for example, the item is the staircase, and we would apply a protective coating system to this staircase to help it achieve its design life. So we wouldn't be talking about the design life of the coating that's applied to protect the item. We're talking about the item being the staircase, and we're talking about applying a coating solution to help that item achieve its design life. And an important misunderstanding when we're talking about protective coating solutions is the reference to the life of the coating, the life of the item. A life until exhaustion is life until the protection or the item would be completely exhausted, so not fit for purpose. But what we reference in the Australian standards when we're talking about recommending a coating system to achieve a durability or a design life, we're talking about life until first maintenance. And this is a really important thing to understand. Life until first maintenance is not exhaustion. It's just a life until it needs to be refreshed or maintained to help achieve the life required. So, to achieve a design life, we need to implement a maintenance program. Because often the life until first maintenance of a protective coating solution to help an item achieve its design life is shorter than the actual life of the structure required. So we need a maintenance solution or a refresh solution to help that item achieve its design life. So life until first maintenance, not life until exhaustion, life until first maintenance is referenced in the AS 2312, which I've said earlier is the requirement by the mandatory requirement is deemed to satisfy a solution to achieve corrosion protection in the National Construction Code. Life to first maintenance, as I've already talked about earlier, is the time elapsed before maintenance is required to refresh the coating system. Importantly, as this was referenced from the AS 2312, it does not indicate failure of the protection, but rather it suggests the time that it needs to be refreshed or maintained to continue on protecting the item. And as we can see by the chart lifted from the standard, we've got a coating system on the left, selected a polyurethane system. We've got a C3 atmospheric corrosivity, and then we can see that when we line all those up, we can provide a 25-year plus durability. That durability is years until first maintenance. So if we had a project that required a 50-year design life, we would apply this coating system and expect at the 25-year mark that we would probably need a refresh or maintenance to refresh that coating to help achieve the design life of the structure. There is also a useful chart in the 2312 that gives an estimate on loss that would be expected if we had bare steel or zinc coated steel. And this chart gives you an estimate that you can calculate the amount of loss that would be expected per year in microns if the steel was left unprotected by a coating system. Now, this has been used sometimes by engineers to estimate if we've got an inaccessible item and we have to achieve a certain period of time, you could make a theoretical decision here to understand the life of your coating system. Understanding the life of the coating system is not till exhaustion, it's life until it would need to be refreshed. But then if it was inaccessible, then you could start to calculate the amount of loss that you would be expecting from that metal, that steel per year in certain atmospheric corrosive environments. So it's a useful chart when trying to estimate the life of protection and life of the item for design life. I've highlighted the C4 there because I have a little calculation which I can show you an example of this later in the presentation. So maintenance. I've talked about sometimes the misunderstanding between life until exhaustion and life until first maintenance. We're talking about life until first maintenance when we're talking about estimating the life of coating systems that are referenced in the standards. And they can be broken down into three simple steps. So step one would be inspecting the steelwork to see what condition it's in. Cleaning is sometimes required. Now, we can't expect that we're going to be going around cleaning a car, cleaning our bridges and our major infrastructure. But if there is a design failure in corrosion protection on the steel where there's an area that's holding dirt or is got pooling or puddling water, these areas would need to be cleaned because the coating system was never designed to be put in these immersed environments, and they're classed as design failures for corrosion. And then we could understand what repairs or refreshes required. So we're not talking about dismantling the structure, removing the structure and taking it back to a workshop. We're just understanding how we can refresh or repair by these three steps. And that here is an example of an inspection rating tool that we would use, where we would have a look at the coating system and understand the damage to it, and then we could make a recommendation on what's required to repair or refresh. In most cases, when we reach the 25-year durability mark of an estimated time to first maintenance, we would usually be expecting number 1 or 2 ratings to be implemented to use to refresh the coating system. Now I can take you on a live example down at Phillip Island in Victoria, where we can actually look at a coating system that's been in service for 20 plus years, a 3 coating system. And as we walk down this pathway, we can see we're over water, so we have a higher concentration of moisture and salt and oxygen, which are the 3 things that cause corrosion. So we've got a higher atmospheric corrosivity environment. If we take a closer look at the handrail, we can see that it's intact. There's no corrosion present. It's suffering some wear and tear most likely from the UV radiation, which is quite high in Australia. If I use my special effect here, I can point out one area where I may have been misleading there and said there's no corrosion. There is one band of corrosion on that handrail or that guardrail. That is a good example of site repairs on weld joints when they're not done to conform with the original system. So you can see the original system is all intact and in place, and we've got a band of corrosion where there's been some welding done, which wasn't, the coating system wasn't installed or applied the same it was for the rest of that guardrail. So this is quite common if when we're talking about weld repairs or site repairs of newly installed steel, if we don't provide the specified coating system that was provided and we just do an on-site quick repair, that area will break down whilst the rest of the system will stay intact. So we're doing our inspection of the guardrail a bit closer now, and we've got our dry film thickness gauge, which measures the microns. So it measures the coating thickness. And by that gauge, we can see we've got 338 microns of coating still in place after 20 plus years. The original coating system would have only been specified at 325. So it hasn't grown. It would have been applied at a higher application than what was specified. But by measuring that coating thickness, we haven't really suffered any loss of the protection of the coating system. What we've suffered is the top coat has broken down. So the colour coat has either chalked or eroded away. So from an evaluation of looking at the coating system after this period, the recommendation would be to clean, sand and reapply just the top coat to reinstall the original coating system. One part that you can see in that photo where Alex has inscribed his name, I think he was inscribing Alex Loves Nicole, has caused what we call mechanical damage to the coating. So if we've got an area that's got mechanical damage, we would have to reinstall the coating thicknesses in those areas to make sure it's consistent with the rest of the coating. And important note that mechanical damage is not referenced in durability, in the durability terms of the standard. Mechanical damage is an unexpected damage that can't be estimated. So mechanical damage is something that would need to be repaired as it happens. Now, I pointed out that chart a little bit earlier in the 2312 table 2.1, that estimated loss of microns per year of bare steel or zinc coated steel. So this is just a bit of a chart just to explain the amount of loss we would have had if that steelwork had no protection on it in this atmospheric corrosivity environment. So going by that chart, over the 20-year period, we would have had a loss of between 1,000 and 1,600 microns if it was bare steel. So 1 millimeter to 1.6 millimeter loss of steel would have occurred in that period if it wasn't protected. If we had zinc-coated steel, we would expect that we would have lost 42 to 84 microns of zinc over that period. So it's important to understand when we're protecting steel and we're trying to provide a design life and a long-term protection, that whilst that coating system is in place, we've had no loss of steel or zinc. That steel or zinc coating is still in exactly the same condition as it was originally installed. So if we are talking about a design life or an expected life, whilst we have a coating system protecting that item, protecting that steel, we are keeping the original item in its original condition. So if we did get 25, 50 years down the track and kept that steel protected, the item, the steel or the galvanizing underneath, would still be in its original state. So it's an important thing to understand when we're providing protection to using protective coatings. As I talked about earlier, warranty is not a reference to achieve durability or design life. The durability reference in the AS2312 refers to the technical performance of the coating system. So specifically, it's life to first maintenance. A warranty is a commercial agreement only covering defects in materials or workmanship. So it's really covering that the materials that have been provided in line with the requirements and the deemed to satisfy by the National Construction Code, which is the Australian standards, are not faulty. And this is referenced from the standard itself, this information. So it's important to understand when we're trying to estimate a durability period, we're not referencing what a warranty period is, because they are two different things. Warranty is covering faulty material, and durability is the estimated life until first maintenance. And you would not measure, if you were to measure the life going by warranty, you'd be measuring the length of time expected that you'd be expecting until it's covered against the defect. And that's not really managing the life of coating systems. So it's important to understand there's two different meanings from warranty and durability. And this is referenced in section 1.7 of the AS2312. So as I explained, and this is a misunderstanding that I see in my role as a specifier for Dulux, a 15-year durability does not imply a 15-year warranty, so they're not the same. So a durability is our time until we'd expect to provide refresh or maintenance, and a warranty is covering that we're not providing faulty materials. So a warranty is usually a shorter time because you could not run a warranty right up until a point where the coating system would need to be replaced, because you wouldn't be really able to justify that if a material is faulty when it's at the end of its durability period to be replaced. So when we talk about warranty, and I have had comments in the construction industry before, a warranty is not worth the piece of paper it's written on because it's got clauses in there. A warranty does add a lot of value and helps you achieve the best performance outcome, because what it does do, and as Sam's explained in his presentation earlier about QA and QC requirements, to achieve a warranty, you need to provide QA documentation to say that you have complied with the specification. And the specifications to pass consumer law from a manufacturer have to reference test data to not be misleading. So, the specifications are a very important part, because the specification is based off test data and compliance. It also requires quality assurance. So it needs to have the applicator sign a legally binding document. What a warranty doesn't do, it doesn't define the durability period. The durability period is referenced by Australian standards. So warranties should be a part of a broader strategy, but not the complete tick box item to achieve your durability requirements for a project. So if we go back to our original page, we can see there are many steps in achieving the risk management, the durability, the design life, the life to first maintenance, and a warranty, and they all work together as one. So part of this presentation was to explain the different parts that we look at when we're providing specification, where warranty actually sits. So, if we're expecting a durability, it's not at the same time as a warranty, but our durability should be referenced by the Australian standards. And to understand that we do have a mandatory requirement to conform to the National Construction Code when we provide specification. So our specification should be aligned with the AS 2312. Thank you. Hopefully that covered off some information with corrosion protection.
Thank you, Adam, for your input. I'd now like to introduce our third and final speaker, Nicole Waterman, Engineering Manager at Langer Rock. With over 20 years of experience, Nicole has held multiple key leadership roles at Langer Rock and is a highly regarded member of the Australian leadership team. Nicole is currently a technical lead in Langer Rock's clients and markets team, and most recently was the project lead for the TAP 3 footbridge, St Mary's, New South Wales. Nicole has delivered multiple complex multidisciplinary infrastructure projects across Australia, Europe, the Middle East and Asia in a range of sectors including rail, education, residential, commercial, cultural and civic, sports and the water and wastewater industries. Please welcome Nicole Waterman.
Thanks very much for that introduction. Very generous. So these sessions, and Sam has done a lot of this already in his presentation around what's required in the construction side and how important it is for quality assurance and quality control. There's a large list of items that we need to do from a construction point of view, and many people have seen these. Your regular inspection and test plans, we'll go a little bit into. Work packs, we talk about at a high level about what's required, and then any non-conformance reporting that we do to close out anything that hasn't gone as planned, as per the plan of the build. And the details, this happens with all items, including the Dulux solutions. We also do a lot of auditing, making sure that we follow our management plans and make sure that we're doing the right things throughout our systems. And many businesses, as you probably are all aware, have their ISO accreditations, which we must maintain. Requirements management is certainly a big thing. My example today is around St Mary's footbridge, which is in the rail corridor and therefore has a large requirements management control that we need to maintain throughout the design and delivery process, which is getting better and better in the rail space. I think over the years, the 10 years I've been working in this space. And then finally is the completions and handover. What does that look like when we hand something over? So they're the elements of my section of the presentation today, but we'll go through those one at a time. So the inspection and test plan process is quite simple. We identify the documents for inspection and then the testing requirements. Then we have what we sometimes call an ITR or an FIC. So an ITR is an inspection test report or a checklist. So these are objectively inspected and recording results, so we have them in individual evidence that we pull together, and then finally we produce any report on any non-compliances against that standard and acceptance criteria. So this is a simple process that we go through on every project and every element, but we'll focus today on the paintings scenarios. So we have a list of things here. Is the ITP is the plan of all inspection and test activities relating to specific discipline to provide evidence of compliance to the specified client and contract requirements, as we talked about in the rail corridor. That can be quite specific. And the ITP shall be developed and approved by the client and the designer. So this is really important. We always make sure that the designer absolutely signs off on the ITP. Sometimes clients want to also sign off on review, or at least review them, at least have sight of them. But sometimes we require them to sign them off. But often the minimum is that the designer will sign off the ITP. And the ITP shall be developed for each discipline. So as I said, this one, the examples today are just for the rail corridor and the painting, but we have lots of other ones for the precast, and they start to build up a story of how we've delivered and what the quality we produce at each time. So there's a certain sequence order that we do these. So the ITP as a sequence order, the inspection testing is to be formed sometimes by a qualified or experienced personnel. That can sometimes be a qualified engineer in our project team or our delivery team. Reference to the applicable project specification is always on the ITP. The codes and standards are there, which you can always review at any time and go back to, and reference, where applicable, to the verification of the records being used. In this case, it can be also, as we said, the FIC or the field inspection checklist. So this is an example from St Mary's, the footbridge of where we've used, and you can see just as a cut example of an ITP is pretty standard across all of our projects, but you can see their item 3.2 is about surface preparation and making sure that the ITP is compliance with the code, both in this case, the Transport for New South Wales codes and the clause in our contract. And the surface preparation and checklist is what we've got here that we've referenced and used in this case. Here is the surveillance report that we received. Now, we talked about in the previous slides there about having a qualified reviewer or an inspector. In this case, we used LMATS as a subcontractor supplied reviewer who is licensed to inspect and check each of their the thickness. In particular, we're asking them to check the thickness of the paint coating. This is a photo is one of our lift shafts that are now lifted in place at St Mary's for the footbridge, so you can see where the inspections have taken place as well. Photos are one of the best things in inspection and test planning records. Then what do we do about non-conformances? Plenty of people, you just hear NCR around the site shed all the time, but a non-conformance is a non-fulfillment of a specified requirement. This is accordance with the Australian standard there of ISO 9000. Product or service that may require rework. It is not constructed correctly or is or in accordance with the contract requirements. Incorrect product or material or failures in any way to be recorded as a non-conformance. So incorrect dimensions, etc., wrong location, wrong materials. In this case, we obviously painting is obviously if we use the wrong one, we make a note of that, and then the test results that are outside the approved tolerances. So the non-conformance report is just a document raised and captured, usually by the construction team, and with a correction methodology or identified the non-conformance to that specification or the standard. This is another example, not of a paint product, but this is one of our an example of our non-conformances. You can see there's a lot of photos, a lot of documentation. And the one thing that people forget about is the cost. Cost of non-conformances is a really big deal in construction. So this is something that we take seriously. It looks like you can see on the third section to the right here, which says what the actual costs are going to be to repair or redo this non-conformance. So there are a couple of ways to resolve a non-conformance. When we normally need, the client will always want to see how or what you've done to close out that non-conformance. The first one is obvious, and it's a rework or repair to make sure that the specified requirement is achieved, and that usually means another inspection and a tick in that box. Except without concession or a use as is. Now, this is one of the classics which our site engineers like to use to make sure to just say, okay, this will do. It should be okay. It's slightly outside outside the requirement. And that happens often with just tolerance of measurements. If you're just a couple of mils out, you can sometimes do that. But this paint is very difficult to compare it to use as is. Repair with a concession. Now, this is really probably the trickiest one, where you have to convince the client to give you a concession on how you and accept a product that is not within their tolerance. So that can be a little bit easier. I find a little bit harder to get through the closeout process. The last one, the next one is one that we really, really hate, which is reject and scrap. We really don't want to redo work that we've spent a lot of money to create and generate. So we will try our best not to do that. And then regrade for an alternate application. So use it somewhere else. So if you need, sometimes if you, the simple one, which is concrete, where you've not quite got your cover, but the requirements for your cover means that we can reduce the durability or do a different application to increase the durability. So you can do that when you regrade it. And then the design change. This is where all the design consultants love to see us when we come through with an RFI or a technical query, to ask them if we can use as is. What is the tolerance with the solution that we've actually built against their requirements and under their drawings and specifications. So these are the ways we can close them out. Another image here on the right is around is our lift shafts again getting relocated. So you can see we often get them inspected a couple of times to make sure that they still comply. And you can see, if you've got really good eyesight, you'll be able to see that this the test result is not satisfactory on this one. We've had a lot of work there. So that's a closeout of the non-conformances is required under the Australian standards. We've got and the clauses there 3.6.6 and 3.6.7 provides some statutory or regulatory non-conformance requirements. And we can specify those as we go. These non-conformances can only be closed out by the certifying authority and to ensure compliance with the statutory and regulatory requirements. So in our case, that's where we have LMATs who can help us do those and close out of the non-conformances. And I'll just close with a couple of slides here, a couple of photos. This is not St Mary's, obviously. This is St Peter's station, very similar as part of our Transport Access Program contract with Transport for New South Wales. These are a completed lift shaft. You can see the Dulux dual coats on these steel structures on these lift shafts as well. And that's the end of my section, so I'll hand back to the MC. Thank you.
That's all the time we have for today, so please join me once again in thanking Sam Hughes, Adam Hocking and Nicole Waterman for their time and input. I'd also like to thank Engineers Australia's long-standing industry partner, Dulux Protective Coatings, for their support. As always, we would appreciate if you could take a couple of moments to complete the short feedback form linked in the description box below. Your input helps us to improve and plan for future sessions. Thank you again for joining us today, and I look forward to seeing you at our next Industry Partners event. Thank you and good afternoon.